Our topic for today is to discuss the physical significance of a gravitational field. Our objectives is to know Newton's universal law of gravitation, to state what is a gravitational field, and to explain its physical significance. So before we go on to our next topic, let's read first what is Newton's universal law of gravitation. Newton's law of universal gravitation states that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between the centers. So, Newton's universal law of gravitation is grammatically expressed as the force is equal to the gravitational constant, which is 6.67 times 10 raised to the power of negative 11 times the mass of the first object and the mass of the second object over the distance between each object. So kay na-discuss naman ni sa previous reporter, let's move on to our main topic. What is gravitational field? A gravitational field or gravitational acceleration field is a vector field used to explain the influences that a body extend into the space around itself. It describes how objects with mass influence the space around them by creating a field that exerts a force on other masses. So as you can see in the picture that I have provided, nga nasiya mga arrow which is pointing to the center of the earth. So the closer the distance of each arrows, the stronger the field, the stronger the gravitational force is on it. So let's take a closer look. On the right side of the slide, you can see is the concept of a gravitational field. So let's give a brief example on how to know the strength of a gravitational field. The field strength is defined as gravity is equal to force over the mass. So our force is the mass of the earth times the acceleration due to the gravity. So the mass of the earth is 5.97 times 10 raised to the power of 24 times the acceleration to the gravity, which is 9.7 meter per second squared, equals to 5.85 times 10 raised to the power of 33. So substitute the force that we have calculated to the expression. So it will become 5.85 times 10 raised to the power of 33 kilogram point meter per second squared over or divided by 5.97 times 10 raised to the power of 24 kilogram, which is the mass of the earth, is equal to 9.8 times 10 raised to the power of 8 or 9.8 meter per second squared. So the strength of of the Earth's gravitational field is 9.8 meter per second squared. Next is let's discuss what is its physical significance. First is the gravitational field lines and strength. The gravitational field can be represented using field lines. As you can see on the given example nga there are arrows. These arrows represents the direction of the gravitational pull towards the center of the earth. It also represents the field or the space that is influenced by the force of the gravity that is called the gravitational field. This line points toward the center of the mass creating the field, and their density represents the field strength. A stronger field is represented by lines that are closer together. So as nagkadaol ang mga nagkadaol ang object sa Earth, which is represented by the lines nga nasa palibot sa atong illustration, is nagkakusog or nagka-stronger ang pag-pull sa object due to the gravity. The closer the object to its center, to the center of the gravity, the stronger is its attraction. And if the longer the distance, the weaker the field. The second one is the gravitational field's interaction with mass. Objects objects placed in a gravitational field experience a force, which is the gravitational force nga atong mabati kung naata sa sud sa usa ka gravitational field. The force depends on both the object's mass and the strength of the gravitational field. So kung ikaw mas bugat ka, mas kusog ang mas kusog or mas paspas ka nga mahatak sa gravitational force to the ground or to the center of the gravity. So this explains the phenomena like objects falling to Earth due to Earth's gravitational field or planets orbiting the Sun due to the Sun's gravitational influence. The third one is the acceleration due to the gravity. The gravitational field at any point near a massive body, like the Earth, determines the acceleration that an object will experience due to the gravity. For example, is near the Earth's surface, the gravitational field strength is approximately 9.8 meter per second squared, meaning all objects experience this constant acceleration regardless of their mass if air resistance is negligible. So as you can see sa provided nga example, nga first is the ball falls from the rest, which is affected by the influence of the acceleration due to the gravity. And if the ball is being released from the rest, the ball acquires a speed of 9.8 meter per second after 1 second. And if the ball has been falling for 2 seconds, therefore it acquires a speed of 19.6 meter per second due to the acceleration influenced by the gravitational pull of the Earth. In conclusion, a gravitational field describes how a massive object exerts influence over the space, causing other objects to accelerate towards it. It plays a fundamental role in shaping the motion of the celestial bodies, determining the trajectories of planets, moons, and other objects in space, as well as in everyday experience like objects falling to ground. And that's all.